Imagine you're walking through a desert. It's scorching hot, the kind of heat that makes the air shimmer like water on the horizon. You're not a tourist. You're not lost. You're actually living here thousands of years ago, somewhere around what we now call the Middle East or North Africa. Your entire world is sand, rock, fire, and survival. You have no smartphone, no GPS, no grocery store to wander into when things get rough. Just you, your tribe, your fire, and an endless expanse of golden nothing stretching out in every direction. Now picture this. Lightning strikes somewhere nearby. Maybe a meteor hits the ground with a force that makes the earth tremble beneath your feet. Or maybe your campfire, which you've been tending carefully because fire is basically the most precious thing in your world, burns so intensely through the night that it melts something beneath it. And when morning comes, when the smoke clears and the embers cool, you crouch down and find something completely alien to everything you've ever seen. It's smooth, it's hard, it catches the early morning sunlight and throws it back at you in a way that nothing in nature has ever done before. It's beautiful and terrifying, and you have absolutely zero framework for understanding what it is. That moment, that exact confusing, awe-filled, slightly terrifying moment is how humanity first encountered glass. And here's the wild part. Nobody invented glass on purpose. Not even close. Glass, arguably one of the most transformative materials in all of human history. The stuff your windows are made of, the stuff your phone screen is made of, the stuff that allowed scientists to peer into microscopes and astronomers to stare at distant galaxies, started as an accident. Multiple accidents, actually, spread across thousands of years and dozens of civilizations, each one stumbling onto this bizarre material and slowly, painfully slowly, figuring out what to do with it. So let's actually break this down, because the story of how ancient humans invented glass is so much stranger and more fascinating than anything you learned in school. The first thing you need to understand is what glass actually is at a fundamental level, because it's weirder than most people think. Glass is not a solid in the traditional sense. Material scientists will tell you it's an amorphous solid, which is a fancy way of saying that at the molecular level, glass is basically a liquid that got confused and forgot to keep moving. When silica, which is just a word for the primary compound found in sand, gets heated to extreme temperatures and then cools rapidly, the molecules don't have time to arrange themselves into a neat crystal structure. They just freeze in place, disordered and chaotic, and that disordered frozen chaos is what gives glass its unique transparent, smooth, hard properties. The universe, as it turns out, already knew this trick long before humans did. Obsidian is volcanic glass. When lava flows and cools rapidly, you get this sleek, dark, razor-sharp natural glass that ancient people absolutely loved. And we know they loved it because archaeologists have found obsidian tools at sites that are tens of thousands of years old. Ancient humans were knapping obsidian, chipping it into blades and arrowheads and cutting tools long before anyone had any concept of what glass actually was. They just knew obsidian was hard, held an incredibly sharp edge, and could be shaped if you knew what you were doing. There's also something called Libyan desert glass, which is this yellow-green translucent material found in the Sahara, specifically in an area between Egypt and Libya. It's absolutely wild stuff. Some of this glass dates back around 26 million years, which obviously has nothing to do with humans, and scientists have spent decades arguing about where it came from. The current best theory is that it was formed either by a meteor impact or by a meteor airburst, essentially an explosion in the atmosphere above the desert that generated enough heat to melt the sand below it. Either way, you get glass. Ancient Egyptians actually picked this stuff up and carved it. A carved piece of Libyan desert glass was found in the tomb of Tutankhamun, set into a breastplate. King Tut was buried with space glass, and that somehow isn't mentioned nearly enough in popular history. But let's talk about the moment humans stopped just finding glass lying around and actually started making it themselves. Because that leap, from observer to creator, is where things get genuinely interesting. The oldest known manufactured glass objects date to around 3500 BCE, and they show up in Mesopotamia and ancient Egypt almost simultaneously. Now, that simultaneity might mean they were trading knowledge, or it might mean that both civilizations independently stumbled onto the same discovery around the same time, which honestly says more about how inevitable the discovery was than about any particular culture's genius. These early glass objects weren't windows or bottles. They were beads. Small, colorful, beautiful beads. Here's how that probably happened. Ancient craftsmen were already working extensively with a material called faience, which is a glazed ceramic material made from crushed quartz or sand mixed with various minerals. They'd heat this mixture to create the glossy colored coating on pottery and small ornamental objects. And at some point, while working with faience or while smelting copper ore, which also involves extremely high temperatures, someone's furnace got hot enough for long enough that a portion of the mixture didn't just glaze over, it vitrified completely. It turned into a blob of actual glass. Think about the moment that craftsman or craftswoman pulled that piece out of the kiln. They'd been doing this job for years, probably decades. They knew what their materials were supposed to look like when they came out. And this was not that. This was something different. This was something they'd never made before. Did they panic? Did they show it to their friends? Did they immediately grasp that they'd created something new, or did it take weeks, months, years of experimentation before they realized what they actually had? We don't know. The historical record doesn't tell us what anyone was thinking in that moment. But we know what they did next because the archaeological evidence is clear. They figured out how to do it again. Deliberately. The earliest manufactured glass beads and small vessels show sophisticated control of color and composition. Ancient Mesopotamian glassmakers discovered early on that adding different metal-like compounds would change the color of the glass. Copper gave you blue-green. Cobalt, which was traded across massive distances specifically because of its value to glassmakers, gave you a vivid, deep blue. Iron could give you yellow-green. Manganese produced purple. These weren't happy accidents. These were deliberate choices made by craftsmen who had developed genuine expertise in manipulating this material. By around 1500 BCE, the Egyptians had established glass workshops that were, by the standards of the ancient world, essentially factories. They were producing glass objects at scale, in standardized forms, with consistent quality. There was a town called Amarna, built by the pharaoh Akhenaten, and it had an entire industrial district that included glassmaking facilities. These were not small operations. This was serious, organized, specialized production, but even at this stage, no one had figured out how to blow glass. Everything was either cast, which means you pour molten glass into a mold, or core formed, which is a technique where you wrap molten glass around a sand core, shape it, let it cool, and then dig out the core from inside. Core forming is extraordinarily labor-intensive. You can imagine the patience required to wrap viscous molten glass around a sand shape without burning yourself catastrophically. Manipulate it while it's still hot enough to work. Add decorative trails of colored glass, and then somehow extract all the sand from inside without breaking the whole thing. The vessels produced this way were small, often tiny, and incredibly precious. They weren't everyday objects. They were luxury goods, status symbols, treasured possessions. A small glass bottle in ancient Egypt was the equivalent of driving a luxury car today. It communicated wealth, taste, connection to skilled craftsmen, and access to rare materials. Then, somewhere around the 1st century BCE, someone had what might be the single most important idea in the entire history of glassmaking. Someone picked up a hollow metal tube, gathered a blob of molten glass on one end, and blew air through the other end. The glass expanded. It formed a bubble. The bubble could be shaped, stretched, twisted, pinched, manipulated in 3 dimensions while the glassblower kept feeding air into it and spinning the tube to keep the shape from collapsing under gravity. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Glassblowing was revolutionary in a way that is genuinely difficult to overstate. Before glassblowing, making a glass vessel was slow, painstaking, and limited in what forms you could produce. After glassblowing, a skilled craftsman could produce a finished vessel in minutes. The forms possible expanded explosively. Thin-walled, lightweight glass became possible for the first time. Production costs dropped dramatically. Suddenly, glass objects that had been reserved for royalty and the extremely wealthy were accessible to the middle classes. This discovery almost certainly happened in the Levant, which is roughly the region of modern Israel, Lebanon, and Syria. The Phoenicians, who were extraordinary maritime traders and craftspeople, are often credited with either the invention or the rapid early adoption and spreading of glassblowing. Within a century of the technique emerging, it had spread across the Roman Empire, and Rome ran with it in a massive way. Roman glassmakers were extraordinary. They developed an incredible range of techniques. Cameo glass involved layering differently colored glass and then carving through the outer layers to create relief images, essentially painting with materials instead of pigments. The Portland vase, which survived from the Roman period and now lives in the British Museum, is one of the most celebrated examples of this technique, and is so technically accomplished that modern glassmakers still find it challenging to replicate. Romans also figured out window glass. Early Roman window glass was cast, which meant it was thick, uneven, and you could see through it only hazily. But it was still window glass. For the first time in history, you could have a room that had light coming in while still being protected from wind and rain. The psychological and practical shift that must have produced in daily life is hard to fully appreciate from where we sit today, surrounded by perfectly transparent glass on every side. Now here's something most people don't think about. The chemistry of glass wasn't understood by any of these ancient craftsmen. Not even slightly. They were operating entirely on empirical knowledge, which means they knew what worked through trial and error, through apprenticeship, through generations of accumulated craft knowledge passed down from master to apprentice. They could tell you that you needed to heat the materials to a certain color, that you needed to add this mineral for this color, that you needed to cool the glass slowly to prevent it from cracking. But they couldn't tell you why any of that worked because the concept of silicon dioxide, of molecular structure, of heat-induced phase transitions was completely unavailable to them. This is one of the most fascinating aspects of the history of technology. The gap between knowing how to do something and understanding why it works is often enormous, and humans frequently close the how gap centuries or even millennia before they close the why gap. Ancient glassmakers were manipulating silicon dioxide at a molecular level with extraordinary skill, and they had no idea that silicon or molecules or atoms existed. The theoretical understanding of what glass actually is chemically didn't come until the development of modern chemistry in the 18th and 19th centuries. But, by that point, glassmakers had already been refining their techniques for well over 3,000 years. The medieval period brought a massive flourishing of a particular form of glass art that you definitely know even if you don't think of it as a technological development: stained glass windows. The Gothic cathedrals of Europe, those soaring, light-flooded structures that were essentially the skyscrapers of their era, used glass as a deliberate architectural and spiritual tool. Light filtered through colored glass was understood as a representation of divine illumination, and the theological implications drove an enormous investment in glass-making technology and artistry. Medieval stained glass was made using a technique called the cylinder method. Glass blowers would blow large cylinders of glass, cut them open while still hot, and flatten them into sheets. These sheets were then cut into pieces, colored with metallite oxides, and assembled into window panels using strips of lead. The lead, which is malleable enough to be shaped around irregular glass pieces and strong enough to hold the whole. Assembly together became the defining characteristic of this art form. The color chemistry of medieval stained glass is still a subject of active research. Some colors that medieval glassmakers achieved, particularly certain deep reds produced using gold nanoparticles, were so vibrant and so specific in their optical properties that modern glass manufacturers spent considerable time reverse engineering how they were made. The craftsmen doing this work didn't know what gold nanoparticles were, obviously. They knew that adding a tiny amount of gold to the melt, then cooling the glass and reheating it, produced this extraordinary red. The why The actual mechanism involving quantum-sized gold particles that interact with light differently than bulk gold does was completely beyond their conceptual framework. Venice became the center of European glass production during the medieval and Renaissance periods, and the Venetian glassmakers, particularly those based on the island of Murano, where they were relocated in the 13th century ostensibly to protect the city from fire, but also arguably to make it easier to control their movements and prevent industrial espionage, were guarding their trade secrets with an intensity that bordered on paranoia. Venetian law at one point made it illegal for a glassmaker to emigrate and teach their techniques to foreign powers. The penalty was reportedly death, or at least the death of the craftsman's family members who remained behind as effective hostages. The thing they were most fiercely protecting was the secret of cristallo, a nearly colorless, highly transparent glass that Venetian craftsmen had developed by carefully decolorizing their glass using manganese dioxide to counteract the green tint that iron impurities in the raw materials would otherwise produce. This almost perfectly clear glass was extraordinary by the standards of the time, and it drove demand across Europe for Venetian products. The next truly transformative development came in 1674, when an English glassmaker named George Ravenscroft patented lead crystal glass. By adding lead oxide to the glass composition, Ravenscroft created a glass that was extraordinarily clear, brilliantly refractive, and relatively easy to cut and engrave. Lead crystal became the dominant material for high-quality drinking vessels and decorative objects across Europe, and it remained so for centuries. The way that cut crystal catches light and throws it into rainbows across a room is entirely a product of that specific chemical composition and its effect on how the material interacts with light. Then, in 1688, the French perfected a new method for making large sheets of flat glass by pouring molten glass onto flat casting tables and then grinding and polishing the surfaces flat. This plate glass process, developed at a factory in Saint-Gobain, produced glass of unprecedented flatness and clarity. Large mirrors suddenly became possible. Large windows became more accessible. The Palace of Versailles, built to showcase the power and sophistication of Louis XIV, featured its Hall of Mirrors, which used this new plate glass technology to create an effect of almost supernatural luminosity and space. The practical and psychological effects of cheap, large, clear glass on European society are difficult to quantify, but clearly enormous. Buildings could let in more light. People could see their own reflections with unprecedented clarity. Scientific instruments that depended on precise optical glass, telescopes, microscopes, spectroscopes, became more capable. The relationship between glass technology and the scientific revolution is not a coincidence. Better lenses meant better observations. Better observations meant better theories. Better theories meant better understanding of the natural world. Galileo's telescope was not an invention from nothing. It was the product of a glassmaking tradition that stretched back to ancient Egypt, refined over thousands of years by craftsmen who had no idea their work would eventually let someone observe the moons of Jupiter. Now here's something worth sitting with for a moment. Throughout all of this history, from the first person who picked up a piece of Libyan desert glass and found it beautiful, through the Egyptian bead makers and the Phoenician glass blowers and the Venetian cristallo masters and George Ravenscroft's lead crystal, there's a through line that has nothing to do with practical utility. People found glass beautiful. Before anyone knew what glass was chemically, before anyone understood why it was transparent or what made it strong or how to predict its behavior precisely, humans were drawn to it aesthetically. The play of light through colored glass, the reflective surface of a polished mirror, the brilliant refraction of a cut crystal. These things produced a response in people that went beyond the rational and into the emotional. Stained glass windows were built to create spiritual experiences. Venice protected its cristallo because beautiful things have always commanded value far beyond their material cost. The Hall of Mirrors was built not because Louis XIV needed to see himself that many times, but because the sheer visual impact of all that reflective luminous glass made people feel something. Glass, in a very real way, has always been as much about human psychology as it has been about human technology. So, what's the actual takeaway here? What does this wild, winding, multi thousand year story actually tell us? It tells us that the most important inventions in human history are almost never the result of a single genius having a single brilliant idea. They're the result of accumulated accident, observation, experimentation, refinement, and knowledge transfer across generations, civilizations, and centuries. Nobody invented glass. Glass was discovered over and over in different places under different circumstances, and then slowly and painstakingly developed through the collective effort of thousands of craftsmen across thousands of years, none of whom could see the full arc of what they were contributing to. The person in Mesopotamia who first noticed a strange glossy blob at the bottom of their kiln and decided to examine it rather than throw it away wasn't thinking about King Tut's breastplate or the Hall of Mirrors or Galileo's telescope or the microscope that would eventually allow scientists to see bacteria and revolutionize medicine. They were just curious. They were paying attention. They were willing to poke at something strange and see what happened. That's it. That's the whole mechanism. Curiosity plus observation plus willingness to experiment, multiplied over thousands of years and millions of individual humans doing their small part, adds up to something as extraordinary as human civilization. And next time you look through a window or glance at your phone screen or catch your reflection in a mirror, maybe take half a second to appreciate the full insane depth of that simple transparent surface. There's about 5,000 years of accumulated human ingenuity sitting between you and the outside world, starting with some confused ancient person crouching in the sand over a strange glowing blob, trying to figure out what on earth they'd just stumbled onto. They had no idea what they'd found. Neither did we, for a very long time. And that's exactly how the best discoveries tend to work.